Hi everyone. So today in this video we are going to see the solutions of the chapter matter in our surroundings. Okay. So let us go for one by one. So here question number 1. Which of the following are matter? So which of the following are matter here? So chair, air, love, smell, hate, almonds, thought, cold drink, smell of perfume. So you all know that matter is nothing but the things which are going to occupy space, right? So in these things which occupy space here, we are having chair. So air also occupies space, you know it. Love, no. Smell, no. Hate, no. Almonds, so these occupy space. Thought, no. Cold, no. Cold drink, yes. Smell of perfume, no. So, chair, air, almonds, and cold drinks are the things which are called as what? Matter, as they occupy the space. So question number 2, give reason for the following observation. So the smell of hot sizzling food reaches you several meters away, but to get the smell from cold food you have to go close. So they are asking that the hot sizzling food we are going to have, the smell is going to reach our nose very easily when we are far, okay, but the smell of the cold food we are not going to get when we are far. We are going to get only when we are closer to that food. So why? Because as the particles of the hot food have more kinetic energy and hence the rate of diffusion is more than the particles of cold food. So the rate of diffusion, that is nothing but the spreading of the particles, is more in hot food when compared to the cold food. That's why the hot food we are going to get the smell very fast when compared to the cold food. Question number 3. A driver is about to cut through water in swimming pool. Which property of matter does this observation show? So, a driver is able to cut through water in swimming pool. This shows that the particles of water have intermolecular space and has less force of attraction. So, intermolecular space and less force of attraction will be present in the water. So, that's the reason why he is going to have the cut through the swimming pool. Okay. So, what are the characters of the particles of matter? So, here this is the important thing you have to remember. So here they are asking the what are the characters of the matter. So as you learned earlier, the characters of the particles of matter are: particles have intermolecular space, that means they are having some space between them. Okay, so this space we are going to call it as what? Intermolecular space. Particles have intermolecular force and they are having some force between them. Okay, that's why they are going to move. That means when two molecules are going to attack, they are going to move. Particles of matter are moving continuously and the particles are going to move continuously here and there. Okay, so this is about characters of the particle. So next question, the mass per unit volume of a substance is called as what? Density. So density, uh, somewhat we can say thickness. Okay, the mass per unit volume of a substance is called as what? Density. So you know that density is nothing but mass by volume. So let us arrange some things in increasing order of their density. Okay, so here density is nothing but you have to remember like weight and thickness. Okay, increasing means small to big. You have to arrange in that manner. So here air density is less than exhaust from chimneys, and chimneys less than cotton, less than water, less than honey, and less than chalk, and less than iron. So if you see properly, iron is having more weight when compared to chalk. Chalk is having more weight when compared to honey. Honey is having more weight when compared to water. So in this way it is going to have. So air is going to fly, you can say. Okay, so this is the increasing order of the density. Tabulate the difference in the characters of states of matter. So now we are going to see the characters of states of matter, and we have to differentiate between them. Okay. So here we are having two questions here. Let us go for the question number, difference between the characters of three states of matter. Okay, so what is the character? Shape, volume, rigidity or fluidity, intermolecular force, intermolecular space, and compressibility. Okay, so let us see what is the shape of the solid. You are going to see it has a fixed shape. Liquid, it doesn't have not fixed shape, and gas is also not having any fixed shape because of the particles present in them. Okay, so solid will be having tight particles, right? Liquid is having somewhat loose, and gas is completely, the particles are very far from each other. Volume is nothing but the inside space, we can say. Okay, they are also, the solid is also having fixed volume, liquid is also having fixed volume, but gases are not having any fixed volume. So rigidity or fluidity, so rigidity is nothing but the strongness, and fluidity is nothing but the flowness. Okay, the flowing thing. Solids are going to flow? No, they are not going to flow. Okay, so they cannot flow, but they are having rigid, that means they are strong. And the liquids, they can flow, but they are not rigid, that means they are not strong. Gases can flow but not rigid. Okay, so intermolecular force. So the force between the solid is maximum, and when compared to solids, we are having, liquid is having less than solids, and gases is very less, as I said, because of the particles itself. Intermolecular space. The intermolecular space is very less in solid. That means for there is no space we are going to see in solid. The particles are tightly packed, so there is no space between two particles. Okay, so the intermolecular space between liquid is more than solids. That means somewhat space we are going to see here. And in gases, the intermolecular space is maximum. That means they are very far to each other. Got it? So compressibility means tightness, we can say. Compressibility is nothing but putting some force on it, and you are going to see the tightness. So if you press any pencil, pen in your hand, are they going to compress? No, it is negligible. You cannot compress the solid. Liquid, yes, compressible, and gas is highly compressible. So if highly compressible, for example, balloon. Okay, if you compress the balloon, it's going to change the shape. If in balloon we add water also, or we can take any liquid, then the liquids are going to shape that kind of shape. So liquids and gases are compressible, but solids are not compressible. So next question. So here, so they asked about, comment on these few definitions here. Rigidity is nothing but the tendency of a substance to retain or maintain their shape when subjected to outside force. That means when we put some force on it, let me explain it properly. Let us take this pencil. Okay, if I put pressure on this pencil, is it going to change the shape? No, it's not going to change the shape. Rigidity is nothing but what? Strongness, we can say in simple. Okay, compressibility, as I said, flexibility. Okay, the matter has intermolecular space. So between the molecules we are having space. Okay, that external force applied on the matter can bring these particles closer. So when we put pressure on this side and this side, what happens to these molecules? They are going to become tight. Yes or no? So this thing we are going to call it as what? Compressibility. So here the external force applied on the matter can bring these particles closer. This property is called compressibility. Okay, so gases and liquids are having compressibility. Why? Because the particles are arranged loosely in liquid and also the gases. So in gases we are going to see the particles are very far, and in liquid the particles are somewhat near. Okay, that's the difference. But in solid we are not going to see the compressibility because the particles are tightly packed. Fluidity is nothing but the flowness, as I said, the flowness. Okay, the tendency of particles to flow is called as what? Fluidity. Liquids and gases are going to flow. So you may having the doubt, if you drop liquid or if you throw water on the floor, you are going to see the flowing of the water, right? That is nothing but liquids. How the gases will flow, you are going to think. So as I said earlier, we are having the smell, right? So if you lighten up the incense sticks, okay, that agarbatti you are going to say, right? That agarbatti, if you lighten up, what happens? You are going to see the smoke effect that is going to move. Okay, that effect we are going to call it as what? Fluidity. Okay, the smoke is also going to flow. Filling of gas container. Gases are particles which vibrate randomly in all the direction. The gas can fill the container. So your HP gas you are going to see, your cylinder. So gases are filled in a particular container also. Okay, so the empty bottle which you are going to hold in your hand, that bottle is also having some gas in it, air in it. Okay, so next, shape. Solids have maximum intermolecular force and definite shape. Solids are having maximum intermolecular force. That means what? They're always tightly arranged. They're going to push each other because they're not getting any space between them. So that's the reason they're having intermolecular force made more, and they're having some particular or definite shape because of this thing only. Okay, whereas liquids and gases takes shape of a container. Okay. Kinetic energy. So kinetic energy is the minimum energy. Okay, the energy possessed by particles due to their motion is called as what? Kinetic energy. Okay, the energy possessed by the particles. That means the particles having some energy, so that they are going to have the movement. So as I said, particles are going to move, right? Why they are moving? Because they are having some energy. So to lift your hand, to write, to walk, to talk, what happened? You are require energy, right? So that energy is nothing but what? Kinetic energy. So in the same way, particles are also having some energy, and that energy is called as what? Kinetic energy. Molecules of gases vibrate randomly as they have maximum kinetic energy. So the molecules of the gases are arranged loosely, right? So they are going to vibrate more. Okay, this molecule is going to dash this, and it is going to move again here and there. Okay, in this way the molecules of gases is having more kinetic energy when compared to solids. Okay, so density, as I said earlier, density is nothing but thickness. Okay, it is defined as mass per unit volume. The solids have highest density. Thickness or more weight. Okay, when we have both these things in a thing, we are going to call that as the density. Okay, in simple. So this is about density. So next questions we are going to see in the next video. So thank you for watching the video. For more videos, please subscribe Go Easy Tutorials. Okay.